Good morning, Algebra students. This is your notes for section 5.1, and I wanted to start by just reviewing the partner activity that you completed very quickly and just talk about a couple of things. So first of all, you can see here I have the two equations that you should have come up with for the cost equation for the first one, the revenue equation for the second one, and then just discuss this is our break-even point, which is some new vocabulary that's going to become really important as we move forward. We'll see this in a lot of the problems we're working on in this unit. Okay, and then here's the table that you should have filled out. And I just wanted to remind you that for this table, using your graphing calculator would be really helpful, because if you take the equations that you came up with up here and just enter one of those equations in your y equal and go to your table of values, you can your calculator will very quickly generate all of these values for you, and you just need to copy them from your table of values. So it's very quick and easy to fill in for a situation like this. And then from that, I can see that once I get to the 10th night, that's the point, that's called our break-even point, where both the cost and the revenue are going to be exactly the same. So that's the answer there. Okay. So moving on, you should have completed the Desmos activity. And again, that was to help you with a little bit with the discovery of systems of linear equations when we're graphing. So remember, we said a system of linear equations is an equation, a set of two equations in two variables. And so that's what we have here. So this follows up very nicely with our last unit on solving linear equations. And so we're going to start with solutions, okay? And it says tell whether the ordered pair is a solution of the system of linear equations. And then your definition is up here. So it says a solution of a system of linear equations is any ordered pair, really, that is a solution of each equation. And actually, I shouldn't say any, because there's only one that is potentially going to work. So the idea is to take this ordered pair that comes in the form of x comma y and plug those values in place of x and y and just check. So in the first equation, when x is 3 and y is 1, excuse me, 3 plus 1 does equal 4, so it works. And then we plug that into the second one. 2 times 3 is 6, minus 1 does not equal 3, so therefore it does not work here. So we would say this is not a solution of this system of equations. Let's check the second one. So we have x is negative 2 and y is 3. So I'm going to just show my work above since I don't have a lot of room here. So when x is negative 2, 3 times negative 2, and then 2 times 3, this gives me negative 6 minus 6, which does equal negative 12. So it is a solution for the first equation. Let's try it down here in the second one. So 2 times negative 2 is negative 4. 4 times 3 is 12. 12 plus negative 4 does not equal 9. So this system, sorry about that, this equation is also not a solution for this system of equations. So it's going to be, again, only one ordered pair that works. So just remember, you have to check it in both. Okay, so let's go down here and look at these three graphs. It says use the graph to solve the system of linear equations. Well, as you discovered in the Desmos activity, this is a pretty simple thing to do. We're just looking for that point of intersection. And again, it's where is that one unique point that is the system, or I should say the solution. And remember, we're going to write that as an ordered pair. So in this case, it's 2, negative 2. And I'll just show you how to check this first one really quickly. So if you were going to check this, what you would need to do is find the equation of these lines. So using slope and y-intercept, I can see that I have a slope of negative 2 and a y-intercept of 0. So the first equation is y equals negative 2x. The equation of the second line is y equals 3 halves x minus 5. And then if you take that ordered pair and plug it in for each of these values of x and y, just like we did above, you would see that it creates a true statement in both of those equations. And as long as you've got a clean point of intersection, you can be pretty sure that that is the correct value. Okay, so let's go ahead and take a look at this next one. So right here, here's our point of intersection. So I would say that's at -1, -3. Okay, and then here's our point of intersection here, and that is at +4, 2. Just remember when you give your solution for the set of systems of linear equations, it should always be written as an ordered pair. Okay, so let's go ahead and move on. That's the easy part. So in this next section, we're going to actually do some graphing, okay? And just a reminder, you have the ability to do your graphing with a straight edge, so please make sure that you're doing that. And then I listed some steps here, so we're going to graph each line in the same coordinate plane. And then again, we're looking for that point of intersection, clearly stated as an ordered pair. Then of course, check your solution back up here. Okay, so I'm going to scoot up just a little bit so I can graph a little easier. So for this first one, y equals -x plus 3. So my y-intercept, I always start with that, is +3. My slope is -1. So down 1 over 1, down 1 over 1, down 1 over 1. Then I'm going to connect that. Again, you're using a straight edge for this. For my second line, okay, this time y equals x plus 5. Here's +5. And my slope is +1, so up 1 over 1. And again, notice I ran out of space. That's why it's important to be able to count our slope backwards. So down 1, back 1, down 1, back 1. Here's my second line. Make sure you do extend your lines all the way across the coordinate plane with a straight edge. I like to circle that point of intersection, and I believe right here it is at, whoops, let me get that back. Okay, sorry. So as an ordered pair, -1, 4. Let's do this next one. For this next set of equations, notice the first one is written in standard form. And this one works out very nicely if you want to graph using intercepts because 3 and 2 are both factors of 6. So when y is 0, x is equal to 2. And when x is 0, y is equal to -3. So I can just plot those points on my graph. So when x is 2 and y is -3, there's my 2 points. Connect those to make a line. Okay, my second equation is y equals -3. That's a horizontal line with a slope of 0. And it's a y equals equation that passes through right here at -3. So here's my point of intersection. Sorry, this one is, don't know where that came from. Let's get rid of that. Okay, 0, -3. This is not liking me. Okay, last graph. Okay, this one's a little bit more complicated, so let's take a look at this. So we have 3x minus 4y equals 7, and if you notice, I can't graph using intercepts because 3 and 4 are not factors of 7. Same thing down here, 5 and 2 are not factors of 3. So my only option here is to change those to slope-intercept form. So in interest of saving a little bit of time, I'm going to I did the work on my paper and you would too, but I'm going to show you the solution. So for the first one, y is 3/4. So you would subtract 3x and divide by -4. So 3/4 x minus 7/4. And for this one, y is equal to -5/2 x plus 3/2. Okay, so what you might notice here is that this one is very messy and not an easy to equations to plot by hand because you have fractions for your slope and for your y-intercept. So this is one that I would recommend going to your graphing calculator on. So I'm going to pause this for a second and try to pull up your graphing calculator. Okay, so I think we're in business. All right, so I'm going to click on my first, go to your y equals and click on your first equation. So y equals, and then I want to put my first equation in, which is 3/4. Remember, to end a fraction, you just do 3 divided by 4. Then I need x, and this one is minus 7/4, so minus 7 divided by 4. Okay, just watch me for a second. You can always rewind and go back and do this yourself if you want to. Now, what we're going to do that's new is put in a second equation. So this time you're going to scroll down and go to your y sub 2, which means your second equation, and enter the second equation. Remember, for a negative, we don't use the subtraction sign. You have to use a negative sign. So go down here, enter negative 5/2 is 5 divided by 2, x, and then plus 3/2, so plus 3 divided by 2, and hit enter. Okay, now the beauty of this is you can already see these, the table and the equations generating on my screen. But if I want to see that show up real big over here, I'm going to go click on graph so you can see what the graphs look like. Don't forget, if needed, you might have to change your window settings, but for this one, we're fine. So you can see both graphs generating on this screen here. Okay, and then for right now, I'm just going to show you how to use the table of values. So let's go to second graph, which will show us our table of values. And then what we're looking for is a value of y. I'm sorry, let me restate that. A value of x where the value of y is the same. So you would just scroll up and down in your table until you can see that. But hopefully you can see that that's happening right here, where x is 1. Both y values are -1. So the solution of this equation is 1, -1. Okay, so hopefully you're good with that calculator instruction. We'll review that when I return. And let's go ahead and look at the real life application problem. So please read through this. The test has 18 questions worth 48 points. It consists of some true-false questions that are 2 points each and some multiple choice questions that are 4 points each. So the first thing we're going to do is clarify our variables. So give a variable statement. So x is going to be the number of 2-point true-false questions. Okay, please remember to be specific with your variable statements. And then y is the number of 4-point, I'm just going to say multiple choice questions. Okay, so we need to write a system of equations to represent this real life problem. So that means we need 2 equations and 2 variables. So equation 1 is going to come from this first, this first sentence up here. Right here, this piece of information. There are a total of 18 questions. So if you have some 2-point questions and some 4-point questions, sorry, my computer's not cooperating there. My first equation is x plus y equals 18. And then my second equation is going to come from this piece of information here. So you have some 2-point questions and some 4 points that are a total of 48 points. So that means you need to multiply 2 by the number of 2-point questions, 4 by the number of 4-point questions to get your total of 48 points. So there are your 2 equations. So we're just going to go over here and graph them. For the first equation, when x plus y equals 18, that one is super easy to graph using x and y intercepts. Because when x is 0, y is 18. When y is 0, x is 18. So I'm going to make sure you're using a straight edge. I don't know how well this is going to work doing it by hand. On this second one, even though I could graph using intercepts, I don't have enough room on this graph, so I have to change it to slope-intercept form. So 4y equals -2x plus 48, 5 by 4 here and here. So y equals -1/2 x plus 12. Okay, so that means my y-intercept is 12, and I go down 1 over 2, down 1 over 2, down 1 over 2. Okay, so it looks like my point of intersection, and you guys obviously with a straight edge can see this much better than what I did here, but I think this is my point of intersection. And I also should have labeled, this is my number of true, false, and this is my number of multiple choice questions, and that helps me easily identify my answer. So in this case, please remember, even though normally we give our answers in ordered pair, make sure that you restate your answer clearly. So this means there were 12 true false questions and then 6 multiple choice questions for a total of 48 points and for a total of 18 questions. And again, you can plug that in and you can check that in the problem. All right, ladies and gentlemen, thank you so much for listening to notes today. Good luck with your assignment, and I will see